Smart factory. See, the modern age of smart factory is driven by data analytics, and the data from the sensors or Internet of devices which you are collecting, utilizing for controlling processes in real time. And we moving towards smart factory, and I will take you through our digital journey so far. See, when we started Industry 4.0 journey as a proof of concept, we have seen some benefits. But we see the data collection from various sources like logbook, DCS, it is also not sufficient. And similarly, from the laboratory reports and SAP, so much of data at different intervals we have to collect, and again cleaning up the data and then stitching up the data and analysis and developing the models and deploying the models. Initial phase it took a lot of time, and we realized the importance of the data. If we have right data, we can get much more benefits. Then we have gone for the historian. It is a software, and it collects the data from various sources, and whenever we required, we can extract immediately. Utilizing this data from the historian, about 100 plus use cases we have implemented, and we have seen the benefits in all aspects, including productivity improvement. This is how actually the procedure of Industry 4.0, the capturing the data and then structuring, cleaning and analyze and developing the model using advanced analytics like random forest, multivariate regression, then developing models and deploying the models. And one use case I will explain, this is about online measurement of chips brightness. In our BCTMP plant, it is wood quality is very, very critical. Not only age and girth, also chip brightness. Even chip brightness varies 3 to 4 degrees also, it will have impact on the quality. You know, the traditional method of wood chips brightness measurement is we have to dry the chips and then polarizing and make it cake and then measure the brightness. It will take at least 24 hours. But we felt the requirement of real-time basis brightness. Then we have invented this. This is actually camera. It captures images from the conveyor where chips is going, and we have isolated this zone to avoid lighting, external lighting. And the camera will capture about 70,000 images in a day. And we have developed a software that captures these images, and then conventional neural networks that predicts the brightness. We have trained the CNN model using the chip's shape, size, and also brightness determined from the lab testing. And with this real-time measurement of the brightness, along with the advanced analytics, we are able to optimize chemical consumption as well as brightness control. And you can see the red is dark chips and blue is brighter chips. And we have used this conventional neural networks method. You know, this to recognize the face, or many places nowadays it is using. It will follow the segmentation, image segmentation based on the color like green, blue, red. The same approach we used here, and we are able to measure the brightness. This is how it will show the brightness trend, and it is taken by the advanced analytics model, and it will predict the brightness. And coming to second use case is productivity improvement digesters. See, one of the constraint for us is recovery boiler capacity constraint. To increase the pulp production, only way is to reduce the solid generation. We have used advanced
Mr.
analytics
Rambabu,
extensively.
sorry. Mr. Rambabu,
Yeah.
please conclude quickly.
Sure.
We have over-exceeded the time.
Yeah.
Please see, we yesterday clearly said
Yeah.
no more than 20-25 slides. If
Okay.
we let you talk for 40 minutes, we don't do the justice with the other round.
Okay, I will take you through.
So that's some time limit you have to follow. And that's our humble request. Yesterday we made this point very, very clear. So kindly conclude, because there are other authors. Either we step in
No, 2-3 minutes I will just complete. This is another use case. We are able to increase the pulp production, various sequences, deployed the models, and coming to third use case also, brightness standard deviation reduction we are able to achieve. Earlier it is brightness standard deviation is 1.2. Today we are at 0.6. It is global benchmark level. And this is how this tracking of the sensors, even online tracking of the tracking and calibration of the sensors. So another model is the equipment reliability improvement. We have developed the dashboards to monitor the efficiency of the pumps and be able to monitor the efficiencies and able to take action in time. And similarly, this BCTMB SC refinery tackles live prediction. That equipment that tackles worn out means it will have impact on the quality. So that we have developed the model. It will predict it will show the life of the tackles. If it reaches 80%, we are able to plan the shutdown and be able to replace the tackles. And similarly, for heat exchangers also, we have developed the model to monitor the heat transfer coefficient. Similarly, for chillers also, we have developed the model for the coefficient of performance. And there are many models developed for the process improvement as well as equipment, reliability improvement, all these helping us improve the efficiency in all aspects. Thank you.